Good evening, good evening. I got a lot of good news. You saw a lot of people passing this week, but I also saw people taking a lot of practice tests. That means they're getting ready to take the test. So I like to see things of that nature. So now I know, Sharon, you said area perimeter problem. T, I know you said an exponent problem. So let's look at that exponent problem first. That's a fairly easy one. Exponents would probably be one of your first five. So if you have 5 to the 7th raised to the 2nd power, right? Is that what you meant, T?
Yes.
Okay, so remember the exponent rule. So the first rule is anything to the 0 power is 1. Anything to the 1st power is the base. When you're multiplying exponents with the same base, you add the exponents. When you're dividing exponents with the same base, you subtract the exponents, top minus bottom. And this one here is when you raise to a power, you multiply. So let me show you what this is. Remember, squared means you're multiplying the same thing twice, right? So this is like saying 5 to the 7th times 5 to the 7th. Always go with what you know. Identify somehow. Even if you didn't know what that was, you put a raise to a power, it's supposed to multiply. Well, 5 to the 7th squared is 5 to the 7th times 5 to the 7th. And then you, again, multiplying exponents with the same base, you add the exponents. So this is 5 to the 14. Okay. 5 to the 14th power. Or you can multiply 7 times 2. So 7 times 2 is 14. 5 to the 14th power. Got me?
Yeah.
Okay, good.
I don't even know what I got on that one.
Let me try to find the one you got wrong. Sharing on the air perimeter, because you got most of them right.
Yeah.
Can I put yours on the screen?
I don't care.
I like to ask.
No, I mean, I don't care.
That's one of the ones you got wrong here.
Yes. Yep. And you know what? I don't even know how. Yeah, I got that one wrong.
So first of all, Tiffany is making a display board for the school play. The display board is 9 by 9. Actually, 9 by 9 is actually a square, but a rectangle is a square is a rectangle, so I can still call it a rectangle. But 9 by 9 is really a square. If ribbon costs $1 per foot, how much will it cost to add a border
4 times 9 is 36. Ding, ding.
Right.
I
overthought
it.
9. The ribbon has to go around. 9. So 9 times 4 is 36. Because it only costs $1 per foot, it's 36 times 1.
It's $36 all day long. Yeah, I did this that night. I know.
Got me? So, yes, but listen, but these are the things. As you go through Schoology, you take more and more quizzes. It may seem like trivial things, but what happens is when you make those small mistakes, but you realize them. So when you get to your test, you won't make those small mistakes. Y'all can't hear me?
It's like you froze.
Can you hear me? Can you hear me? Can anybody hear me? Testing, 1, 2, 3. Can you hear me?
Well, I can hear you now. I can hear you now. Yeah.
Yes, we can hear you.
Which one? Okay. All right. I can't hear you now.
Yeah, I can't hear you either.
How about now? Can you hear me now?
Yes.
Yes.
Okay, so my internet is unstable for whatever reason. So this is the perimeter is 36, and because it's $1 per foot, it'd be 36 times 1. If it was $2 per foot, you did 36 times 2.
2.
Right. Okay. So that's that. Again, by practicing and seeing these small mistakes that a lot of people are making, this is why you take the quizzes, take these assessments over. So when you get to your test, you won't make those small mistakes. A lot of people over the break got this one wrong. Number 10. You got it right. But 3 or 4 other people did this problem over the weekend. Patricia has a rectangular garden that is 10 feet long and 4.5 feet wide.
Oh, yeah.
One bag of soil covered 10 square feet or 10 feet square. How many bags would she need to cover the garden? Okay, so first of all, you have to find the area because it says to cover the garden. So that means inside, that's area. So area equal length times width.
Yep.
So 4.5 is 4.5 is 4.5
go ahead.
times 10. This will multiplying by 10, we're just moving the decimal one place to the left. So the area of this flower garden was 45 square feet. Each bag of soil is 10. So we have to divide. Okay? So we're going to do 45 divided by 10 is equal to 4.5 bags. This is the mistake everybody was making. Almost everybody chose 4. If you need 4.5 bags, but you only buy 4 bags, do you have enough to finish covering the garden?
No, you don't.
No, so you have to buy that 5th bag. So the answer here is 5. Now, would you have extra left? Yes, but at least you'd be able to cover the whole garden. So the answer here is 5 bags. Everybody understand that?
Yep.
Okay, good. All right, any other question? I saw, I think I saw a Penny come in. Who else did I see come in? I saw 2. Darlene.
Yes.
When are you gonna take this science now? Come on now, let's go, let's go.
I have my date, the 28th, April 28th.
Okay, good. So make sure.
Actually, I need a 1-to-1 to set up a 1-to-1 with you.
Definitely. So we want to make sure we knock that out. And anybody been working on anything this week that gave them?
I can't hear you. You
issue?
breaking up.
Yes,
I'm still breaking up. Can you hear me now? Can you hear me now?
Mr. Kenzie, you breaking up. I can't hear you.
Yeah, I hear you now.
I don't want to, because then I have to leave.
I can hear you now.
You can hear me now? Okay.
Yes.
Let me look at another question for exponents. Just let me see if I can find one real quick. Put this back over here. This was Sharon's. And again, what you should see, and I don't mean to have people overconfident or not confident enough. What you should notice is that my exams are a little bit harder than the actual exam. Why? It's because I got fill-ins, I got matching. I want to make sure you know it.
Yeah.
A lot of the GED is multiple choice, so you can eliminate some answers. But I want you to be so prepared that when you take your exam, you're ready. Okay. So let me find an exponent problem that gave people issues over the weekend. Oh, this one right here. Let me write this down. Let me get it. So if I said, I'm not going to use the same one. I'm going to do 9 to the 3rd times 9 to the minus 6. What would that answer be? What would that answer be? 9 to the 3rd times 9 to the minus 6.
9, -9.
Nope.
Don't you have to add? You have to add to stay alike. I don't know. I got this wrong too. I don't know.
Right. So what happens? People know the rules, but when they see negative numbers, it seems like they just lose their mind.
Oh, subtract, right?
No. When you multiply, let's go. Understand the rules. When you're multiplying exponents with the same base, what do?
You add
the exponent.
So you add the exponent. So 3 plus minus 6.
So it'd be
so now
-3, nah.
-3, because this becomes 3 minus 6, just -3. So your answer would be 9 to the -3rd power, or 1 over 9 to the 3rd power, or 1 over 27. Okay, so recently, we've been having problems like this among the first 5. Remember, they're not going to have a negative exponent. Okay, so you have to understand whatever that orientation is, you got to reverse it. So if it's on the top, you got to put it on the bottom. If it's on the bottom, you got to put it on the top. In this case, I put 9 to the third is 1 over 27. Nobody even stopped me. Nobody even
That's when you
said that's
subtracting
wrong.
though, right?
So that's not 9 to the third power is
I
not
said,
27.
no, right when you subtract,
It's
you're
81.
supposed
I don't know what
He
this
said
is.
9.
81, 729.
Third.
729. Now you're not going to see
Oh.
that. They're going to put it in. They're going to put it in
729.
exponent form. So that's why on an exponent quiz I say put it in exponent form. Let me ask you. Let me ask you a question.
Yeah. That I didn't understand that.
Let me if I had something
Go
like
ahead.
this. Let me do something like this. Let me do
It's 729. That's what that is.
x to the third, y to the seventh, z to the first over 12 x to the fifth,
Oh God.
y to the 12th, e to the third. How would we do something like this?
Okay.
it's dividing, so
It's division. So when you have exponents with the same base, what are you going to do?
subtract.
You're going to subtract. Okay.
Yeah.
So,
That's
but the
X and
first
5.
thing we're
Okay.
going to look at, and this is very important because a lot of people
Oh,
make
yeah.
mistakes on these, is first we look at things that are alike. So we look at the 8 and the 12. What's the greatest common factor of 8 and 12?
4.
4. So 4 going to 8 how many times?
2 times.
2. How many times is 4 going to 12?
3.
3.
3 times. Okay. So we got the 2 up top, got the 3 down the bottom. The next thing we're going to look at.
Okay. The X and the 5. I mean,
let me change these up a little bit. Let me change them up a little bit. Let me change that to a 3. Okay, so we got, so now we're looking at the X's because they have the same base. And because we're dividing, right, it's 3 minus 5, which is what?
-2.
Negative 2. So we got X to the negative second power. Everybody understand that?
Yes.
Okay, now we're going to go to the Y's.
4.
We got 7 minus 3, which is what?
4.
4.
4. So that's Y to the 4th power.
Okay.
And then the last set, and I shouldn't have put Z to the first, so let me erase that also. Let me erase that because you never see a 1.
Nope.
So let me put that the way it is. Now, so, but understand if you don't see an exponent, it's a 1.
That's a 1.
So 1 minus 3 is what?
-2.
-2. So we got Z to the negative second. So now, again, let's look at this very closely. Remember what Mr. Tinsley, you should be hearing me in your ear when you're taking that math exam. If you don't hear me in your ear, that means you ain't studied long enough. But listen, remember what I tell you. You have a negative exponent. You won't see an answer with a negative exponent on the GED, so you have to make it positive. So if it's on the top, where are we going to put it?
At the bottom?
At the bottom. So we have 2 and the 3. They're going to stay the same. The X to the negative second becomes X squared. So you change the orientation and change the sign from negative to positive. My Y to the 4th is positive, so that's going to stay up top. And how about my Z to the negative second? Is that going to be on the top or the bottom?
We're going to have Y4. No.
You must be raining here because you keep going out.
It's not raining where I'm at. It's okay.
So what's happened since Z to the negative second? Can you hear me?
I hear you now.
I hear you.
So where's it going to go, on the top or the bottom?
Which
to
one?
The bottom.
On the bottom.
Oh,
and
that goes to the bottom.
And the -2 becomes a what?
A positive 2.
A positive 2. So this is the answer you will see on the multiple choice. Okay, so I'm gonna make another one up real quick. And I'm just gonna gonna make it up so we just understand how to use the negative. So let's do 14 49 x to the second x y to the 7 y squared z to the 5th z to the 12th.
Lord.
And that's what people say, Lord have mercy, that looks hard. No, it's not. If you
Oh, okay.
prepare yourself, you should be
Okay.
looking at these problems and say, no, I know what Mr. Tinsley told me to do. He said, look at like, so we're gonna look at the numbers first. 14 to 49,
14
what's
and
the greatest
14.
common factor?
7.
7. 7 goes into 14 how many times?
2 times. And 7
7
goes
go
into
into 49 how
7.
many times?
Seven
So we got our
times.
2, we got our 7.
Mhm.
Now, what are we looking at next?
X squared and X.
X squared divided by X. So when we're dividing exponents with the same base, what do?
We add.
We're
So-
dividing exponents with the same base. We do what?
We subtract. We subtract.
So
we
now,
subtract.
if I don't see the exponent for that X, what
It's
is
a
it?
1. It's a
It's
1.
1. So
2
2
minus
minus
1
1 is what?
It's 1. Yeah.
1. So X to the first power, do I need to put the 1?
No.
No.
Put the,
All right,
put the
let's
X.
go to the Y's. They have the same base. When exponents have the same base and you're dividing exponents
subtract.
with the same base, you subtract. So we got
It'd be
y to the
5.
7th divided
It's
by
5.
y second, which is 7
It's-
minus 2,
It's
which
5.
is 5. So we got y to the 5th.
Okay.
Y to the 5th. Now the last step, or the last one, is my z's. Again, this you have to remember this. When you're dividing
Negative.
exponents with the same base, you subtract top
Negative
minus
7.
bottom.
Mhm.
Z to the 5th divided by z to the 12th, which is
Negative
5
7.
minus 12, which is negative 7. So we have
7, yeah.
z to the negative 7. Are we going to keep
Okay.
a negative exponent negative?
No, we're gonna bring
make
it down to the
positive
bottom and make it
and make it
Z.
positive.
Yeah.
Exactly. So we're going to put the z to the 7th, and we're going to
Mhm.
move it to the bottom,
Mhm.
and that negative exponent becomes what?
Now you
The
positive.
negative
Positive.
becomes positive. So now your answer, your final answer would be 2x y to the 5th divided by 7z to the 7th. Mr. Tinsley, when are you ever going to use something like that? It don't matter. You
That's
need to
it.
know the exponent rules.
Well, I've never had this before. I've never had.
Right. Now,
Yeah.
I'm going to give one last one before we
Wow.
leave exponent. Give one last one. So let's do 4
Yeah.
to the 7th times
Mhm.
3 to the 2nd times
Uh-oh.
4 to the 2nd times 3 to the 3rd power.
Okay, so you're doing distributive property with this one. Wait,
Why would you do distributive property? Do you see anything on the outside of parentheses?
No, I don't.
And then the other thing you got to remember is what?
Tim does. Do everything
Okay.
that's inside
If
of
you see more than one operator,
parentheses.
the first thing you should be doing, excuse my
the
dear self,
inside.
it's your
Is
order
the
of operations.
Is in the inside, starting inside.
Parentheses.
So parentheses
first.
is first. Can we simplify anything inside of parentheses?
No,
Can
you
we?
can't.
No, we
Because they
cannot. So we're going
No.
to
No.
this is a 3. Let me erase that.
Exactly.
Oh, okay.
That's a 3. Make sure we got it. So we're not going to do anything with the parentheses. Come on, John. So it's nothing we can simplify in the parentheses. So now we go to exponents. And is there anything exponents that we can simplify?
Unless you
Yeah.
add them. I mean, no, because they're
Which
not
one?
the same, right?
Which ones?
You can do 4 times 4 times 4.
Nope. So remember, we're
No.
doing it in exponent form. So we're not doing 4 times 4 times 4. We're doing an exponent form. So
Mm-mm.
here,
You thought
this 3,
over
is-
here. Oh,
this whole parentheses is raised to a power. So that's
Raised.
what we're going to do next, because that's an exponent. Even though we have exponents inside the parentheses, we can't simplify them anymore.
no.
Okay,
Right.
so these are going to stay the same. 4 to the 3rd
Yeah.
times 3 squared times Now this, when you have raised to a power, what do? What operation do we do to the exponents?
Okay.
I forgot that one.
Do we okay, do we time it?
We
The
multiply.
whole multiply
Yeah.
the whole
Yeah, you
So what is
multiply
3
the 2
times
and the
2?
3. 6.
6.
Yeah.
So we have 4 to the 6
Mm-hmm.
So hungry.
times what? What are we gonna have next?
3 to the 9, right?
Nope.
Wait a minute.
Oh yeah, the exponent is 3 to the 1 because it's not a 1 that's
Exactly.
Right,
It's a
right. It's
1.
3. It's 3. That's
Right.
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 That's right. That's
So
right.
1 times 3 is 3. So we
3.
have 3
Mhm.
to the 3rd power. This is the
Mhm.
mistake
Right.
that most people make right there. When they don't see that 1, that's the mistake they make right there. So
And
4
it's
to the 3rd
invisible.
times 3 squared times 4 to the 6th times 3 to the 3rd. What you should also understand, the associative property tells us it doesn't matter what order we multiply.
I know I had it
So
backwards.
now we got to
Right.
use our rules. Okay, what's the
Okay.
next rule we should use?
Okay, the next rule is everything that's the same.
The same, the 4 and the 3, the 4 to the 3rd power and the 4 to the 6th power.
And
So
what do we do?
it would be 4, 9.
4 to the 3rd
Mhm.
times 4 to the 6th is
Mhm.
4 to the 9th
9.
power.
Mhm.
What's the next thing we should do?
The next one, 3 to the 2nd power and 3
Mhm.
to
3 to
the
the 1.
3rd cube. 3 cubed is
And what's 3
3 fifths.
squared times 3 to the 3rd?
3 fifths. 3 to the
Not
5th
3
power.
fifths,
3 to the 5th power.
3 to the 5th power.
Yeah.
So our final answer is 4 to the 9th
9
times 3 to the
times
5th.
3 to the 5th power.
Ain't
Got to
that
be
something?
ready for that. You almost, I'm pretty sure you're going to have something like that. Exponent rules on your
Wow.
exam. One of the first 5. Be
Excuse
ready.
me, Mr. Tisley.
Yes, yes.
On your practice GED 3,
Mhm.
there's one just like this I was having a problem with is which expression is equivalent. X mine negative 2y to the 3rd over y.
Mhm.
Can you explain that, please?
You said x to the negative 2nd,
Yeah, y and
y to the 3rd.
over
What?
y.
So,
And
Oh, wow.
so
Wow.
wonderful. I love it. I love it. I love it. You want to simplify this. So
Oh, X to the
what are we
2nd.
going to do with this x first?
We're gonna bring it to the bottom and make it
We're gonna-
positive.
We're going to bring it to the bottom, make it positive. Perfect. Second thing we're going to do is what?
Okay. The y, bring up.
That's
Oh,
1
y my
exactly.
3 minus 1 is y2. There.
Final answer right there.
Yep.
wow.
See, I see it now. I understand it better.
And that's why it's important as you're doing this practice during the week, over the weekends, because I see a lot of people did work over the weekend. As you're doing this work over the weekends or you're doing it during the week, the ones you're having problems with, make sure you write down. Sometimes it's just not worth it to spend 45 minutes to try to figure out a problem. You say, you know what? Monday's coming up. I'm gonna hold this for Mr. Tensley, or take a picture, send it to me to my cell phone, or send it to me in an email. I saw, now I'm not saying any names, but I saw a person take a practice GED and spend 11 minutes on one problem. You have to understand, you are not spending more than 3 minutes on a problem. If you are, pick A or D, flag it for review, and get going. Finish that exam. Come back to that problem once you finish, but you cannot spend 11 minutes on one problem. You cannot. Most people do not pass the math exam because they don't finish. Okay, but good question about exponents. What's some other problems we've been working on? that we need help with? Oh, I know one. I saw a couple people get this wrong. It said, give me, it said, I'm just gonna make something up. It says, a square dance floor has a perimeter
A square, okay.
of 160 feet,
Oh, I did that one.
right?
Say it again. Oh,
A square dance floor.
has a
You know what? You know
perimeter
what?
of
You're
100.
right. I write hardly. I'll type it in.
A square dance floor has a perimeter. So that means all the way around.
Round, yeah.
That's a perimeter of 160 feet.
All the way around.
Oh, okay, 160 feet. So you can just need to find the value of all the 4 sides.
Oh my
So
goodness.
So if you,
40. Oh, I
So
know, 40.
I saw quite a few people get this problem incorrect. So I wanted to make sure I touched on it. Some people, they were just given the perimeter. Some people were given the length of one side. What am I trying to, if it says a square dance floor. So okay, when I say identify your givens, what are they giving me? What do you need to extrapolate from this question that you're going to need? Can anybody tell me that?
Okay, they gave you the perimeter.
perimeter of
So it said,
160
what is the length? Or you just looking for the length of the diagonal?
diagonal.
So it's 40 feet.
It's a
What's 40?
That's
square.
what I got. 40 feet 40 feet square foot. I think I'm saying it right. 40 feet square.
The first thing you want to do while you're practicing, draw
Just
something.
draw it out. Yeah.
That's what I
Draw
did. I
something.
draw it.
So if the
draw it.
perimeter, if it have a square, so
Mhm.
when I'm talking about identify givens, the first thing you should be, oops, let me change this to red. The first thing you should be identified is you have a square. The second thing you should be identified is the perimeter is 160. The third thing you
Right.
should be identified is they want to know the length of the diagonal.
That's the one.
So
Right.
if it's a square, that means all sides are what?
Both sides are
The
equal.
same.
All
They the
sides are equal.
same.
All
Yep.
sides are equal. If I know all sides are equal, I'm dividing that 160 by what?
4,
4.
Mhm.
What's 160 divided by 4?
4.
40.
40, I mean. I'm
So
sorry.
that means each side
It's
is
40.
40. Does everybody understand that? So people
40
were
feet.
answering 40. No, that's not what they
40 all
want
the
to
way
know.
around.
They want to know the length of the what?
The length of the length of the diagonal.
That diagonal. So the diagonal go from corner to corner. This is what
Right.
they want to know here.
Oh,
So they make it like
wow.
a square. I
So-
mean, a
so-
triangle.
A triangle. So how do we find the missing side of a right triangle?
Use the Pythagorean theorem.
I don't know what you just said, but
Pythagorean.
Whatever, that's it.
I mean,
the Pythagorean theorem.
Pythagorean theorem.
What is the Pythagorean theorem?
Oh Lord.
A squared plus B squared plus C
A squared plus B squared equal
equals C.
C squared.
Equal C, yeah.
C squared.
So when I look at this square dance floor and I look at all my sides are 40, right? What's my A, what's my B, and what's my C? What sides are my A, B, and C?
Okay, if he your A and B
your length.
40
The width is 40. Look like
and that is 40. Yes, your
And
A
it's
and B you got
40.
solve for C. Yeah.
So my A and B are 40.
Oh.
Remember, the side opposite the hypotenuse
So
is your
it's
C.
80.
Mm-hmm.
It's
We got
80.
40s 40, no, not 80. What does
Mm-mm.
a squared mean?
You gotta double it. You
40
gotta
squared, which is
Okay, so
40
it's a
times
squared,
40.
40 times 40
yes,
is
yes,
80.
yeah.
40 times
Yeah.
40 is not 80.
No, it's not.
Hold on.
40 squared is
160,
1600.
1600.
1600.
160. Huh?
Yeah, you gotta square it.
Remember, 40 squared is 40 times
Oh, yeah,
40.
1600,
Any
1600.
number squared. It doesn't matter what it is. So, for example, earlier,
1600.
T, when you talk about 5 to the 7th squared,
Yeah.
5 to the 7th squared is 5 to the 7th times 5 to the 7th. 40 squared is 40 times 40. 8 squared
Mhm.
is 8 times 8.
8 times 8. Mhm.
3.1 squared is 3.1 times 3.1. You can't get shaken up with square means. It's 40 squared means I'm multiplying by itself. So 1600 plus 1600 is 3200.
Well, you got me with that diagonal. So now that I know when they say diagonal in the word
Oh,
problem, that means
So again, diagonal is a key word. They love using the word diagonal, and then people get lost in what they're doing. Which that diagonal creates that right triangle. That's how you know to use Pythagorean theorem.
Thanks for letting me know that.
Now, I'm gonna do this by hand, then I'm gonna use the calculator because I wouldn't even waste my time doing this by hand. I would make sure I know how to do Pythagorean theorem with my calculator. Oh, because Mr. Tinsley said I'm guaranteed to have a Pythagorean theorem problem. So let me make sure I know how to do it, but I'm gonna do it by hand. So the highest square that I can think of right now, right, is 1600. Matter of fact, I'll break it down for you. I'm gonna break it down. I'm not gonna do 1600 times 2 because that's really 3200, right? So I'm gonna do say I didn't realize. So I'm gonna do 100 times the square root of 32, right?
really?
Watch this. The square root of 32, right, is the square root of 16 times the square root of 2. Why? Because 100 times 32 is 3200. 16 times 2 is 32. What's the square root of 100?
10.
10. What's the square root of 16?
4.
4.
4. Remember I told you should know all your squares and your square roots. What's 10 times 4?
40.
40.
So your answer to this question is 40 square root of 2. So if you want to know this now, okay, Mr. Tinsley, well, what if they don't have an answer as a radical? Remember, 40 square root of 2. So now I'm gonna show you how to do it using the calculator. I showed you by hand our answer is 40 square root of 2. Watch this. Now I'm gonna show you with the calculator because you saw how long it took us by hand.
Yeah.
So it's not 40 feet, so it's 40 square root of 2.
40 square root of 2. That is not 40 times 2. 40 square root of 2. So watch this. Let me clear this out. Now, let me draw it again. So make sure we don't forget what we're doing here. We had that diagonal. We had the 40, 40. We know that this is the side opposite the hypotenuse. I know how to do the missing side of a missing triangle on my calculator because Mr. Tinsley showed me. He said, if I'm trying to find the hypotenuse, I'm doing the square root of a squared plus b squared, which is the square root of 40 squared plus 40 squared. That's what Mr. Tinsley told me to do. So let's see how long it takes. Square root of 40 squared plus 40 squared. Get out of my square root, press enter. Oh, hold on. What number is that? That's not what we got. I thought we got 40 square root 2. Did we get the same number? Did we get the same thing?
That's what I got.
Still 40 square root of 2. The reason why I put that on there, because this is called what's called a 45-45-90 triangle. Okay, so I'm gonna give you a little shortcut. If you ever, at any time, I don't care when, if at any time you have a right triangle and the two legs are the same, the hypotenuse is that leg times the square root of 2. I don't care what the two legs are. It could be 100 and 100. The hypotenuse is 100 square root of 2.
But this was a good one because it was a trick with the diagonal. I was just assuming that this was a square,
So that's
and
gonna
I'm
be
glad you said diagonal so that we can know to really pay attention to the word problem.
Those are the key words. So that's why if you look at the Pythagorean theorem pre-test and the assessments that I have, I give you ones that have shadows with ladders. I give you ones with diagonals in the park, diagonals on an LCD computer screen, south and east, because if you go on south, that's down, east is to the right. That's what you just formed, right triangle. So make sure, especially the ones I'm telling you guaranteed to be on your exam. I'm telling you, make sure you're ready for any problem like that. So that's that 45, 45, 90 triangle. If both of the legs are the same, I don't care what they give you. They could give you variables. They could give you X and X. You know the hypotenuse is X square root of 2.
All right.
Always. Now, I can tell you this. You're going to have a Pythagorean theorem problem on your test. If you're taking college entrance exam, you're going to have Pythagorean theorem on your test. If you're taking SATs, you're going to have Pythagorean theorem on your test. If you're taking your T's test, you're going to have Pythagorean theorem on your test.
Yeah.
Be ready. Guaranteed. All right. What's next?
I still want to do, go ahead.
No, y'all go. I go after y'all.
Anybody. It doesn't matter.
I wanted to do the compound probability.
Compound probability. Let me
Yeah,
find
because
one.
I got confused again. It was do the one with the dice thing. The one, not the one you got. No, the card, the 52 deck. You pick one. You pick one club, and then you got to pick another club or something like that. I forgot. I should have wrote it down.
So the probability of picking one club than another club. It don't matter.
You know that. That's what people play cards. I don't know that.
So the probability
Yeah, 52. Yeah, go
of
ahead.
selecting a club. Did it say replacement or without replacement?
No, it wasn't like that.
It had to be.
It could have been. I don't know. I don't think. No, it's like, okay, you pick one club out of, you got 52 deck of cards and you pick one club. What's the probability of you picking the second club or something like that?
Okay, so probability of selecting the club without replacement, selecting a second club.
Yeah.
All right. So, how do you, what is probability? How do you find the probability? So probability, in fact, I'm not going to write all that, the word. I'm just going to say the probability, right?
Like fraction.
It is a fraction, but how do we figure it out?
It is, it's desired outcome. I mean,
Say, girl.
You can say this, desired outcome.
No, go.
Yeah. Select outcome from the desired outcome.
You can say desired or select, it doesn't matter. So basically what I'm saying is if you say probability of picking a club, okay, so I would need to know the number of clubs
total. Yeah,
over the total number of cards. So whatever that probability is, that's what your numerator is going to be. So let me ask you a question. How many cards in a deck?
The total.
It's 52 cards in a deck.
There are 52 cards in a deck. How many suits are in the deck?
You got
Well,
spades. You got spades, clubs, diamonds, and hearts. 4.
So it's gonna be 4 out of 52.
So
trust me, I have
if I know there's 4 suits in each deck of cards, how many cards are in each suit?
That's what I didn't know because I was trying to. It's 13. I know it now because I had to
13.
count.
Because again,
right.
remember look at the key words. I'm splitting the deck up by suit. So when you split something up,
Okay.
it's division.
Right. Okay.
So
Okay.
52 divided by 4 is 13 cards in each suit. Understand that?
Okay.
Okay, so how many clubs are in the deck?
Oh, it's 13 clubs in the deck.
13 clubs in the deck. How many total cards are there in the deck?
52.
52. So 13 going to 13 once, 13 going to 52 4 times. So the probability of
Oh, my
picking a
God.
club is 1 out of
Wow.
4.
There's 1 out of
Does
4.
everybody
Okay.
understand that? So the probability of picking a club is 1 out of 4. Why? Because there's 13 clubs and 52 total cards. But I added a little wrinkle in there.
Yes,
I didn't
you
just
did.
ask about one club.
Yeah,
I said, what's the probability of picking a first club and then picking a second club? So this is going to be your first club. 1 out of 4. The probability, I'm going to have to move up here, of picking a second club without replacement. That means I'm not putting the card back. So I took that club, I pulled it out, and I'm not putting it back. How many clubs do I have in the deck now?
Oh, you got
Well,
you
51.
got no.
Now, how many
Well-
clubs do I have in the deck now? If I
If he
took a
took
club
one
out,
out, he already took one out, so that made it 12, 11.
12, 11,
12.
12,
I'm
okay.
sorry, 12.
12, because I took one out, I didn't put it
That-
back. So I got
That's
12
right,
clubs.
it's 12. Right.
Now, that same club that I took out, how many cards do I have left now? How many total
the-
cards do I have?
I don't play cards. I
got
don't know.
50.
I'm lost.
51.
51.
51.
If he took
Remember.
2 of them out.
No, I didn't take 2 of them out.
51,
I took
okay.
1 card out.
You took
It
one.
happened to be a club.
Yeah.
So I got 12 clubs left,
Yeah.
51 cards total.
Yeah.
Now,
Okay.
with compound probability, that's more than one event.
So you
What
only
am
had to
what am
take
I
the
going to
1,
do
4.
with this probability of selecting the first club and this
Yeah.
one picking the second club? What operation am I going to do?
You gonna cross more? I mean,
Divide.
is he gonna cross do something, cross multiply? Or let me see.
So that means
I know we got
people must ain't been in that book. Real simple. This is what you
No,
should know.
I
It should be in your
divide.
brain. If I have more than one event for the purpose of this GED,
you got
probability is
two
much harder than what you see here. The only thing they're going to ask you in the GED is
You
either
cross
simple
multiply
probability
and
or
divide.
compound probability. Simple probability is just what we just did. We're doing it over and over again. That's simple probability. Compound probability is more than one event. So all we're going to do is multiply.
So multiply.
1/4 times 12 over 51. 4 going to 4 one time, 4 going to 12 3 times. We're going to multiply across. We get 3 over 51.
Oh,
Now,
okay. She
They
said
might ask
that.
you for the fraction. They might ask you for the decimal. They might ask you for the percent. You better be ready. So now, again, 12, hold on, let me get the calculator.
Okay.
Hold on, because you need to understand that it needs to be a process when you see probability on this test. So is it one event or is it multiple events? If it's multiple events, it's compound probability and you're going to be multiplying. Okay, so our first probability was 13 over 52.
They told me the stuff was still cooking.
If you use the calculator, it automatically reduces the fraction for you. The second fraction, ND, 12 over 51. It already reduces it for you. I got to multiply those two. 1/4 times 4 over 17. What's my decimal? What's my percent? Compound probability. More than one event, you're multiplying the two together. So the probability of the first event, the simple probability of the second event, then you multiply them together. Okay, Mr. Tinsley, I don't know if I really understand that. Okay, so what is Mr. Tinsley telling you? Probability is going to be 1 or 2 questions. I wouldn't spend a whole lot of time on probability. It's only going to be 1 or 2 questions. So don't waste 2 days studying probability. Make sure you understand simple probability and have some understanding as much as you can for compound probability. But I would not spend a whole lot of time on probability because you're only going to have 1 or 2 questions. Okay, so if we look at the study guide, do I have it open? Do I have it open? They give you this crazy question on the, I don't have it open. Let me open it up real quick.
Before you go, can we do one ascending or descending order?
Yeah, a lot of people had a problem with that. A lot of people had a problem with it over the weekend. Come on, computer. I'm having problems here. There we go. But it's the one thing. Let me try to find it. And I'm gonna ask you: is this simple probability or compound probability? And this is what you ask yourself when you're doing the problems. The same thing that I'm asking you, you're gonna do almost every example that you see. Here we go, right here. Probability of an event. In the shipment of toys from a manufacturer, the probability that a toy is defective is 1 out of 50. If Mary selects 2 toys from a shipment, what's the probability that both toys are defective? Wow. I don't even want to do that problem, Ms. Dizzy.
So toys from the shipment, what's the probability?
Does anybody know how I would start this problem? Does anybody know how I would even start this problem? And it doesn't matter who. Does anybody know how to start this problem?
Okay, in a shipment of toys from manufacturer, the probability that a toy is defective is 1 out of 50. If Marie selects 2 from the shipment, the probability that both are defective. What is the probability? Wait, the probability that both.
Cross multiply?
Okay, cross. I would just say that.
What do you mean cross multiply? What do you mean cross multiply? I don't know what that means. Cross multiply what?
50,
First of all, identify your givens. What are they giving? What do you
50.
know?
1 over 50.
So the probability that the toy is defective is 1 over 50. So the probability of a defective toy is 1 over 50. That's what you know. What else do you know?
Right. If she selects 2 from the shipment,
She selects 2 toys from the shipment. Is this simple probability or compound probability?
it's compound.
How do you know it's compound?
Because you're doing 2 things.
You're doing
You're
2
doing 2
things.
things. You're picking 1 toy, then you're picking another toy. Are we?
Right.
So the probability of the first toy being defective is what?
It's 1 out of 50.
Is 1 over 50. The probability of picking a second defective toy is also what?
1 out of 50.
1 out of 50. Since it's compound
2
probability,
out of 50, right?
what are we going to do to those 2 probabilities?
What's the probability that both toys are defective?
So hold on. So let's don't make it hard. You're making it too hard. Identify what's given. Identify what you know. Identify as a simple probability or compound probability. You told me the probability of picking the first defective toy is 1 out of 50. You told me the probability of picking the second defective toy was also 1 out of 50. So since it's more than one event, what operation do we do to the 2 probabilities?
So we're going to cross multiply?
Where
Divide.
does cross multiplier come from? Where does cross multiplier mean?
Okay, okay, no, we're going to,
What operation are we going to do?
Divide.
Where'd you get the division from?
Do we have
I'm
them?
thinking 2 out of.
there's 2 out of, okay, if you got
Yeah,
52.
listen, you think, I'm telling you what to think. If you
Okay.
have more than one event happen, it is compound probability. We are
Okay.
multiplying the probabilities together.
Okay.
So you got 1 times 1 is 1.
2 out of 50.
1 out of 50 times 1 out of 50. I don't know where you got 4 out
So
of
50
from.
times 50.
So when you
So-
multiply, again, I don't know where the cross multiplications come from. I don't know where all this is
I
coming
th-
from. We
okay.
multiply.
Oh, because I'm thinking about
Now, if you're multiplying numbers that might cancel, that's called cross
half and
canceling.
Okay,
Cross multiplying is used when you're trying to see if something is proportional.
right
Okay.
proportions.
Right.
That's what I'm
So
thinking.
here, this is something
Okay,
different.
okay.
1 times 1 is what?
1.
1,
1,
1, and 50 times 50 is what?
1,000.
It's
50
2,500.
2,500.
Oh,
It's
I'm sorry.
2,500.
Remember, mental
I'm
math
thinking
is real easy.
Yeah. Oh my God.
5 times
25.
5 is what?
25.
5 is 25. I
zeros
add
do
the
I have?
0. 2.
2.
0, 0. You right.
2,500.
2,500.
So my probability of selecting 2
It's
defective
1 out of
toys,
2,500.
1 out of 2,500. So a company's going to say, hold on, 1 out of 2,500, that ain't that bad. We're going to go ahead and go with that. We ain't going to
Yep.
fix that. That's what companies
Nope.
do. Is it more expensive to fix the problem or have some defective problems? That's why TJ Maxx and all these TJ Maxx home goods, that's why they're in existence. Because they take the defective stuff and say, you know what, we'll sell it for half price. We'll give it to
Yep.
Marshalls, we'll give it to TJ Maxx, we give it to Home Goods. But we're not gonna lose our money. We're not gonna go fix the problem. It's a couple of
Right.
defective. Oh, we can deal with that. Again,
Mhm.
simple probability, selected outcomes over total outcome. Compound probability, more than one event. So you find the simple probabilities of each event and then you multiply them together. That's all you got to remember for probability.
all-
So
all.
tonight, go home, say, you know what? Mr. Tenney said, don't worry about it too much. It's only going to be 1 or 2 problems. So go home, do the pre-test for probability, see how many you can get.
Right.
If you getting 5, 6 out of 10, 7 out of 10, move on.
Mhm.
Don't worry about it. You know how to do it. It ain't don't waste too much
Okay.
time. It's only 1
So
or
it's
2
not
questions
got
on
it
probability.
probability. I need every point I could get.
I know that's right.
'Cause I would have sure been doing it like proportions. I'm glad you explained that. Thank you, Mr. Tinsley.
No problem. All right, so it is already 7 o'clock, and I got a meeting at 7. So
Okay.
I do have to get right off at 7 this evening.
Okay.
Okay, Mr. Tinsley.
So again,
Okay.
continue to practice. Continue to practice on Schoology. I'm getting the feedback, pretty good feedback from the test. It should be about 6 to 7 people that should be taking the exams very soon. So I want you to remember that if you bought the ebook, schedule that 1-to-1 session before you take your exam.
Mr. Tinsley, I know I don't want to take you back, but I need a 1-to-1 with you.
Make sure you schedule. You still got the link?
I'm not sure. Can you please send it to me?
I sure will.
Okay,
Me
thank you
too,
very much. I'll send it back immediately.
Same here. If I
Me
could see you before Thursday, anytime.
Me too. I remember Thursday because
Do me a favor, because everybody said me too. Send me an email so I remind
this
myself.
Miss Jones.
Send me
I'll
an
send you
email.
an email.
All right, have a
Thank
good night,
you.
man. Thank you.
Everybody have a
I'll
good
see
night.
y'all.
Good night.
Y'all have a good night.
Bye.
Bye-bye.
You too. Good night.
Bye-bye.
Bye-bye.